Hi everyone, welcome to this video on energy transfers, the fourth lesson in the particles and energy unit. The main thing we want students to be able to do by the end of this lesson is to be able to draw energy transfer diagrams based on concrete scenarios. And in many ways, it's just building on what we did at the end of the last lesson on energy stores. The only extra bit is putting an arrow in and showing energy transfers. And one thing that we'll need to teach students about in this lesson is the four ways that energy can be transferred, the four pathways or transfer pathways, whatever you want to call them. That is mechanical, electric, heating, and radiation. So I think the best thing to do with this lesson is not spend too much time talking. Just get straight into concrete examples, because it's one of those topics where the concept that we want them to think about, which ultimately will be conservation of energy, but in this case it's just the formalism, the way we write down the equations. The best way to do that is to get into examples. So I would start, and this is a kind of the structure of this lesson is I do, we do, you do. I would start by modeling one, and then they can have a go on whiteboards at another one, which is slightly more complicated, and then I might go back under the visualizer. So it's a bit back and forth here, but hopefully by using that structure, we get students really thinking at all times during the lesson. And I would start with just a really simple example of a car traveling along a flat road. Now, I quite like to do little cars like this, little cartoon kind of cars like this, but you can just draw a box or whatever you want. So I'm going to draw a car like this, and I'm going to get students to draw with me. Again, not everyone likes to get students to draw, but I'm going to do it in this case. Got a car, and at this point I'll put not moving, or I might give them the keyword stationary and tell them that means not moving. I've just realised I've not given myself enough room in this book, but anyway, hopefully you get the idea. So stationary, not moving. It's not essential at this stage that you give them that language, but I'm going to give it them anyway. And then I'm going to draw the same car. I'm going to try and draw the same car. Let's say a few seconds later. Time isn't that important at this stage. Seems to have changed shape a bit, but hopefully you get the idea. And now this car is going to be moving, and I'm just going to make up a speed, let's say 20 miles per hour. And again, I don't want to, at this stage I'm not introducing equations or anything like that, so I'm not going to worry about meters per second. I'm going to use something very familiar because this is for year 7, so I'm going to stick with the units of miles per hour. Because they'll all have seen road signs and speed limits and so on. And all I want to do is map this picture, which is very everyday, very relatable. They can all understand this. Map it to how we would think about this as physicists, how we would think about this in terms of energy stores and transfers. And I would question students and elicit the idea, or I might just go straight to telling them, well, how is energy being stored here? We've got energy in the bank. It's a form of potential energy, and actually it's chemical potential energy. Sorry, potential. And that's being stored in the fuel. Like this. And then I'm going to do the same thing over here and say, well, okay, how is energy being stored over in this example? And it's no longer potential energy, it's no longer energy that's in the bank. This is energy that's actually being used. I've got kinetic energy in the car. Being stored by the car, I should say. Now, this is nothing that students didn't do in the previous lesson, which was about identifying energy stores. What we're going to add here, the level of complexity we're going to add, one is we're going to draw an arrow. But again, from my experience, that's not something students are overly concerned about. All we're doing is saying something happened. This is why we talk about the events. At these events, in this case, I guess putting your foot down in the driver's seat. At these events, some change happens. we transfer energy from one store to another. In this case, we spend the energy that we had in the bank in the form of chemical potential energy. But what's important here is that we introduce the way energy is transferred. So in this case, it's mechanically. So I'm going to write that like this. Now, I would go through that and I would give them all the details. What I might ask them to do next is say, well, okay, let's consider an electric car. And again, you don't need to draw if you don't want, but I quite like to draw, and I think students quite like it as well. So let's consider an electric car this time. And I might want to just question them and make sure that they're clear that electric cars run on batteries rather than on petrol or another fuel. Again, I'm going to say over here, this is stationary. Over here, it's going at, let's say, 20 miles per hour again. And I would ask them to have a go on whiteboards and say, well, how do you draw the energy transfer diagram here? Now, what they'll probably do is write something along these lines. They'll probably write chemical potential, battery, and kinetic in the car. And then just put a big arrow in the middle and write mechanically again. But actually, what we can do here, when we go back under the visualizer and explain this, is say, well, it's a little bit more complicated than that, in that something happens in the motor. So first, if this is the motor here, first, actually, from the battery to the motor, there is an electrical transfer. So I might put electrically here. And then it's the motor that does that mechanical transfer of energy to the car. Now we're going to see an electrical transfer of energy again, but it's just a nice way of introducing this second way of transferring energy, which is electrically. And I need to put mechanically in here again, don't I, as well? Mechanically. So I'm going to do something similar with, firstly, a candle. So again, what I'm going to do here is show a candle that's not lit over here. And then over here, I'll show them a candle that is lit, like this. And I will probably model this, again, maybe with some questioning, so we could do some sort of co-construction, something like that. But what I want them to understand is that we've got a chemical potential energy store, chemical potential in the candle or in the wax. And over here, now this is where it gets interesting. There's kind of two things going on here, and this is what I'm going to want to model to them. One thing that I'm increasing here is the thermal energy store of the surroundings. So I'm going to show them here that the main way energy is being transferred here, most of the energy is actually going to be transferred in this way. And this is an energy transfer called heating. So effectively, I'm raising the temperature of the air around the candle. But there's this other way of transferring energy here as well, which they may pick up on, which is that the candle is giving out light. So actually what's also happening here is that there's a second way of transferring energy, which is as follows, and that's radiation. That means it's giving out light. Now this is a tricky one, because what energy store increases as a consequence of that? Well, I don't really know. I mean, I don't know exactly, and maybe someone does. If they do and they're watching this video, please get in touch and let me know. But for me, it doesn't feel like the light there is going to increase any energy store. I mean, you could say it's increasing some sort of energy within the surroundings if light is absorbed by something. But really, I think we can just kind of ignore that and say we just need to remember that there's this other way of transferring energy from the wax, which is through radiation. Yeah, it's a tricky one to explain to students, but they need to recognise that there are two things going on. And then the final thing I might do is the light bulb, and that's a similar one here. So again, I might get them to do that on whiteboards, although I think they'll struggle. And it's really important that we go through this because it's one that comes up again and again. And in this case, the way I would draw it for a light bulb, I might not even do this kind of before and after there because it's a little bit more complicated. Let me move down here. So for the light bulb, and we'll come back to this in the next lesson on useful and wasted energy. But what we want to illustrate here, maybe if I move down like this, is energy is coming in electrically. And the way we could draw this is something like this. It's coming in electrically to the light bulb. But again, the light bulb is not really storing any energy. All it does is somehow changes the pathways of that energy. So the energy comes in electrically. That's how it's transferred in. Now again, this is where the store is a bit mysterious, because what is the store? I mean, it's come from the national grid. It could be anything. It could be biofuels, it could be coal, it could be nuclear. We don't really know. We just know that it comes in electrically. So again, students may not be mega happy with this, but they've got to I would say they've got to leave this blank because they don't know where that energy was stored originally, unless it's come from a battery. What they do know is that it comes out in two ways, which I'm going to draw like this. And again, this is just a nice way of illustrating these other two energy transfers. One is heating and one is radiation. So those four examples I think are quite nice because they illustrate lots of different ideas and some of the trickier parts of energy transfer diagrams. And then what you'll see is there are, I think, 8 more examples which your students can practice. In the next lesson, we'll begin to look at useful and wasted energy.